So hey guys, this is Abhishek Rai again, and I'm back with another amazing video about the application of this BFS algorithm. Okay, so BFS, as you all know, it stands for breadth first search algorithm. So it stands for breadth first search. Okay, so this is one of the traversal algorithm in graph theory, and in the previous video we had discussed about this BFS algorithm in depth. So there's a video 45 minutes long that I made previous to this particular video. So in case you want to know about the BFS algorithm in depth, so you can just watch that video. But then if you already have the knowledge about like how BFS algorithm works, so just feel free to skip that video and you can just continue with this video itself. Right. So in this video, like we would be discussing about like how the LinkedIn connections are structured, and we'll try to apply our BFS algorithm on the LinkedIn connections. Okay. So more on that in the later part of this video. All right. So the example here, right, this particular example, the LinkedIn connection example and the BFS example that I'm going to be discussing here. So this is something of my original, and you might not find it anywhere else. So there might be places that can be improved in terms of the space complexity or time complexity, or maybe the code quality could have been like better. Okay, so feel free to drop a comment about these kind of things in the comment section, so that like people who are viewing this video, right, they can look into the comment section as well, and they can learn from your comments too. Okay, so either they learn it from my video or they learn it from the comment section. The ultimate aim is that the people who land upon this video, right, so they should be learning something from here and be going right. Okay, so let's have a like quick intro about what exactly is LinkedIn. Like most of you would already be knowing what exactly is LinkedIn, but then people who are coming from different source on this video who are not there on LinkedIn, let me give a quick intro about what exactly it is. So LinkedIn is the world's it is the world's largest professional network. Okay, it's the world's largest professional network. Okay, so the key point here is professional network. So just like how you have, like you must be like most of you would be familiar with how Facebook works or how Instagram works, right? So in Facebook and Instagram, what do? You send a friend request to some random person or the person who you already know that exists on Facebook. So you just send a friend request to them, and whenever they accept the friend request, so you both become friends of each other, right? So in the similar manner, in LinkedIn, we have user profiles, that is like LinkedIn profiles, and these LinkedIn profiles or these users can send connection request to the other users. Like say similar to like how Facebook works, here you send a connection request to the other user. So the moment the other person accepts a connection request, you both become a connection to each other. Okay. So now let's talk about what exactly is a LinkedIn user. Okay, so who is a LinkedIn user? So any person who has a LinkedIn account is a LinkedIn user. So he or she, so they can be a student or they can be a working professional, okay, or any random person in existence. So any person who has a LinkedIn account is called a LinkedIn user. Okay, so every LinkedIn profile will be having these sections that I've like jotted down the points here, right? So every LinkedIn profile will be having these particular sections, which will showcase your unique professional journey to the other LinkedIn users. So you have the about section where you can write the details about yourself in a paragraph. Say for example, you are a very good competitive programmer, or you are actively contributing in open source technology, or you are a full stack developer and like building web applications, etc, etc. So all those kind of things you can write in the about section. So this is something that will give the other users a gist about you. Okay, then next comes the featured section. So the featured section would be containing all the links about your internet presence. Okay, so internet, what do I mean by internet presence is like if at all you have a YouTube channel. Okay, so you can put the link to that YouTube channel in the featured section. If at all you have a personal blog, or if you are an active writer on medium.com. Okay, so those kind of links you can be putting inside the featured section. Next comes the experience section. So if at all you are a working professional, so you can just write the details about your current company here, or the companies that you have worked in the past and in what role, etc, etc. So all those kind of details you can be putting inside the experience section. Next comes the education section. So like where did you do your BTech, or where did you do your schooling, or in case you have an MBA degree, right? So where did you do your MBA from? Okay, so all those kind of information you can be putting inside the education section. Now next comes the projects. So whatever projects that you have done in your life. Okay, so this can be any full stack web application if you are a software engineer, or a college student, you might have done a lot of projects, right? So like what are those projects? Like if at all there's a web application, and if at all you have hosted a web application on the internet, so all those links, etc., and the description about the project, you can be putting under this project section, right? So next comes the honors and rewards. So honors and rewards basically refers to like if at all you were rewarded for something exceptional that you have done, or maybe example, you secured a given rank in a competitive exam, or you have a certification for something. Okay, so all those kind of things you can mention over in the honors and rewards section. Next, coming to the connections, and there is one more called skills. Okay, so skills is something like what exactly are you good at? So you might be good at C++, or you might be good at Java, Python, or React.js, or JavaScript. Okay, so all those kind of things, basically their skill set, maybe public speaking or something. So all those kind of skills you can be mentioned in the skills section. And then you have something called as connections. So connections are the LinkedIn users who are directly connected to you. So either you would have sent a connection request to them, or they would have sent a connection request to you, and either of the party would have accepted the connection request. Okay, so the moment either of the party accepts the connection request, they become the connection of each other. Now coming to what exactly are first, second, and third on LinkedIn, right? So in case you are confused about what exactly am I talking about, so here in the LinkedIn profile, right, whenever you open a profile of any of the connection, you can see that the name of the connection would be written over here. So I've just scratched the names and the address and the description about these connections, so that just to maintain their information confidential. So the point that I want to focus over here is this particular value. So here you can see it's written first, and similarly in the bottom connection, you can see that here it's written second. So what exactly is this first and second value is what I'm going to explain you right now. Okay, so these first, second, and third, etc. So these are known as the degree of the connection. Okay, so you have first, then you have second, and then you have third. Okay, so LinkedIn has first, second, and third, and anything that doesn't come under first, second, and third degree are termed as others. Okay, so we won't be talking about others here, but then here we have first, second, and third. Okay, so these are known as the degree of the connection. Okay, so these are the degree of the connection. So consider that this is my LinkedIn profile, and there is another user called A. Now A sends me a connection request. Okay, so the A sends me a connection request, and the moment I accept his connection request, we both become first degree connection to each other. Okay, so that is known as first degree connection. So the acceptance of the connection request is the necessary condition to become a first degree connection to a user. Okay, so this is about first degree connection. So according to this, what exactly is a first degree connection? So first degree connections are those people who you are directly connected to because you have accepted their invitation to connect, or they have accepted your invitation to connect. Okay, so you'll see the first degree icon next to their name in the search results and in their profile as well. Okay, so you can contact them by using the direct messaging feature. That is like they can just initiate a chat with you using the direct messaging service, right? So this guy was my first degree connection. So that's the reason why here I'm able to see first written. So that is about the first degree connection. Now second degree connection are the connections to my first degree connection. Right, so here my profile is there, then A is my first degree connection because maybe one of us have like sent a connection request and other of us have accepted it. Okay, so this A becomes my first degree connection. Now the connections to A, okay, so say for example B and C are connections to A, but then B and C are not connected to me directly, right? So A was my first degree connection. Now B and C, they become my second degree connection. Right, so these are the connection to my first degree connection, and that's the reason why you'll be able to see second over here. Okay, so in the example here, so this second, so this guy, he was not my first degree connection, but then he must be a connection to one of my first degree connection. Okay, he must be a connection to one of my first degree connection, and that's the reason why I'm able to see a second mentioned over here. Okay, so this is my second degree connection. Okay, so people who are connected to your first degree connection. So these are connected to first degree connection. So these are the people who are connected to your first degree connection, and you'll see a second degree icon next to their name in the search results or in their profile. Okay, so whenever you go and click their name, right, or whenever you search for their names in LinkedIn, the search result will be having second written next to their name. Okay, so here it will be something like ABC. Okay, and then this second would be written. Okay, so this kind of format would be present. So next comes the third degree connection. So as you would have already predicted, the third degree connections are the connections to your second degree connections. Okay, so these are the connections to your second degree connections. Okay, so say for example, I am over here. Okay, and A and B had sent me a connection request and I had accepted the connection request. So they become my first degree connection. Okay, so A and B become my first degree connection. Okay, now there must be connection to A and B as well. Okay, so who might not be connected to me, right? Okay, so say for example, A has a connection named C, and then we have someone called D, and then B has someone called E. Okay, so E, D and C, they are not directly connected to me, but then they are connected to my first degree connection, and that's the reason why it makes them my second degree connection. Okay, so these would be my second degree connection. Okay, now the connection to my second degree connection, okay, who are not directly connected to me, will be my third degree connection. Okay, so say for example, E has someone called F and C will have someone called G, and then you have someone called H, right? Okay, so these people, so these F, okay, so this F would be my third, G also third, H also third degree connection. Okay, the pattern that you can see over here is how many jumps do you need to reach that particular connection, right? So in order to reach C, I need to make 2 jumps, that is from here to here. Okay, so that would be my second degree connection. In order to reach F, how many jumps do I need to make? I need to make the first jump over here, then second jump over here, and third jump over here. And that's the reason why this is called my third degree connection. So you got the meaning of first, second and third, right? Now there might be other connections as well. So G might also have some connection, maybe some 1 or maybe 2. Okay, so 1 and 2 are beyond my third degree connection. So these would be termed as others. Okay, so these would be termed as others. So others में 1 और 2 आएगा हमारा, ठीक है? Just make a note that these are first, second and third degree connections from my perspective. Now similarly, if you do the same thing from the perspective of C, right? Okay, so C का यहाँ पे क्या होगा? C का यहाँ पे first degree connections होगा A, H and G. Second degree connection होगा 1, 2, D and me. Okay, so these would be the second degree connection and so on and so forth. Okay, so all these first, second and third value are relative to a LinkedIn user. Okay, so मेरे perspective में मेरा first, second, third कोई और हो सकता है. C के perspective में उसका first, second, third कोई और हो सकता है. F के perspective में first, second, third कोई और हो सकता है. Okay, so like that it goes on. So now let's move on to the implementation part of this particular thing, that is the this. So here you can see that these connections are structured in the form of graph. Okay, and we would be running our BFS algorithm on this particular graph itself. Okay, so we'll just try to get all our first degree connections, second degree connection, third degree connections, and if at all we have some computation to do, we can try to do that as well. Okay, so the example that I would be taking here would be this particular graph over here. Each node of this graph represents a LinkedIn user, and in the center of the graph you can see that this is my node. So let's consider that this node is going to be the starting node, and we will be starting our BFS journey from this particular node over here. Okay, and let me mark my first degree, second degree and third degree connections over here. So B, A and F become my first degree connection. Okay, so this becomes my first, this also becomes my first degree connection, and A also becomes my first degree connection. Okay, so let me circle that as well. So these are my first degree connections, right? Now the connection to my first degree connections are my second degree connection. So let me mark all my second degree connection. So here this one becomes one of my second degree connection. C is one of my second degree connection. Then we have G and H as my second degree connections. So I, C, G and H become my second degree connection. Then my third degree connection is, I can see only one of these, that is D. D becomes my third degree connection. So since E is beyond my third degree connection, so this would be categorized under others. Cool. So let us try to implement this particular graph over here, and let's try to implement our BFS algorithm as well. Okay, so here as you can see, I've opened my Visual Studio Code editor. Okay, so the very first thing that we are going to be doing is we are going to be implementing our structure for the LinkedIn user object. Okay, so here each of these node represents a LinkedIn user, and for the sake of simplicity, let's assume that each of these node, right, each of the LinkedIn user has these fields. Okay, so each of the LinkedIn user has a username, then he will have then he has a list of skills. So example, you have C++, then you might have Java, then you have React. Okay, so this would be a list of skills, kind of an array. Then username would be of type string. Okay, and then you have a set of connections. Okay, so set of string. Okay, and this would be the set of all the first degree connections. Okay, the only information that you are storing here is all the set of first degree connections of a LinkedIn user. So there are other information as well that you can store along with it, but then for the sake of simplicity, I'm assuming that our LinkedIn user object contains only these three fields. That is a username, which is of type string, and this username is unique to each LinkedIn user. And then you have an array of skills. Then you have a set of all the LinkedIn connections that are your first degree connections. Okay, so this is how we will be implementing our adjacency list. Okay, so adjacency list, so we cannot make use of array over here. So that's the reason why I've made use of a set data structure to contain all the adjacent nodes to a given node. Okay, so let's go ahead and just code this LinkedIn user structure. Okay, so how would we write it as? So how do we write it as? So we'll just write it as struct. Okay, so LinkedIn user. Okay, so let me put a semicolon as well. Okay, so here the very first thing that we had was a username. So I'll just write string name. Okay, so you can just write username as well. Okay, so string username. Okay, and then you have a vector of string, and I'll just tell it to be skills. Okay, so vector of string of skills. So basically representing this particular thing over here. Okay, so username is done, the skills vector is done, and then what do we have is we have a set of all the connections. So this set would be containing all the usernames of the LinkedIn profiles. Okay, so it will be containing something like these values. Okay, and that's the reason why I have put the data type here to be the string data type. Okay, so let's complete our implementation over here. So here we have a vector of skills, and then you have set of string and connections. Okay, so this defines our all the three attributes. So now let's declare our constructor. So you have LinkedIn user. Okay, so LinkedIn user. First, let me declare an empty constructor. Okay, so now I'll be declaring the parameterized constructor. So I'll be having something like LinkedIn user string name, that is the username. Okay, so string username, and then I'll have a vector of string skills. Okay, and then I'll be assigning the username to username. String username is equal to username. String username to username, and the skills to skills. Okay, so it looks something like this. Okay, so now let's have a function that can print the details of this particular object. Okay, so I'll have something like void print user. Okay, and let's print the name first. So name is this of username. Okay, and the total number of skills, like how many skills does it have? So total skills would be this of skills. Since skills is a vector of string, so I'll just have this of skills dot size. Okay, so this of skills dot size will give us the total skills that are present inside the skills vector. And in case you also want to print like how many connection does this particular LinkedIn user have, so you can do something like total connections of this user is of this user. Instead of this user, you can say of this of username is, and you can just simply say this of connections dot size. Okay, so this connections of size will give you the total number of connection, the first degree connection that are there for the username. Okay, so this is how our LinkedIn user update looks like. So now let's declare a map which can store the username to the user mapping. Okay, username to the LinkedIn user mapping. Okay, so we'll have map of string and LinkedIn user. LinkedIn user, and let's call it to be LinkedIn users. Okay, so this would be something like a select star query. So select star from LinkedIn user, LinkedIn user, where username is equal to some username. Okay, so this kind of query, so ideally this would be coming from a database, but then here, just to mock it, we will be storing the username to the user mapping. That is, you just apply me the username, I'll give you the LinkedIn user, the entire object basically. Okay, so this kind of mapping we are storing in this LinkedIn user variable. Okay, so let's declare some of the objects in the main function. So I'll have something like LinkedIn user of me is equal to new LinkedIn user. Is equal to new LinkedIn user, and I'll name it and I'll call it as Abhishek Rai, or maybe let's name it as me. Okay, and my skills are maybe like C++ and Java. Okay, now what I want to do is I want to add some more objects. So I've done creating my LinkedIn users. So here it will basically create a new LinkedIn user. So these are the keys, that is me, A, B, C, D, etc. are the usernames, and upon these usernames, these particular objects would be accessible from this particular map. Okay, so the time complexity for accessing a particular user by a username would be order of login. Okay, so now we're done with the creation of the users. Okay, so now the LinkedIn users have been created. Now what we need to do is we need to add a function that can add an edge between the users. Okay, so this is commonly known as the add edge function in the graphs. Okay, so in the previous implementations also you would have seen like how I implement the adjacency list. So we have a function called add edge function which can establish an edge between a source and destination. Okay, so here the source and destination would be the two LinkedIn user, wherein in between the two LinkedIn users you need to establish a connection edge. Okay, so that would be a first degree connection edge, right? So our add edge function would look something like this. So void add edge. Okay, so here we need to have a source username. So source username, and we need to have a destination username. Okay, so we have a source username and destination username, and we need to add a connection between the source and destination username. Okay, so how do we do that? So I'll just simply do LinkedIn user of source username, okay, of source username of connections dot insert, okay, destination username. Okay, so with this particular statement, what I'm doing is I'm just accessing the user object of the source username. Okay, I'm just accessing the LinkedIn user object of the source username and accessing the connection set. So here you can see that connection set is basically a set of strings. I'm just adding the destination username to the connection set over here. So the destination username would be added to the set of connections of the source username. Okay, so similarly we need to add the source username in the connection list of destination username, okay, by a statement something like this. Okay, so this here is establishing a bidirectional edge, establishing undirected edge basically. So this is establishing an undirected edge between the source username and destination username. Okay, so here we are done with the function that can add an edge between the user. So now let's make use of this add edge function to add these edges to the graph. Okay, so here as you can see over here, so these black lines, right? So these are the edges between the different LinkedIn users. Okay, so we need to establish these edges in our graph. Okay, so how do we do that? So let's target these edges first. So in between me and A, B and F, we need to have an edge. So I'll do something like add edge, and I will put me and between A. Okay, similarly I'll have an edge between me A, me F and me B. Okay, B and F. This is a capital B and F. Okay, so these edges are done. Now we have an edge between AG and AH. Okay, so I will do something like add edge AG and AH. Okay, and AH, this is going to be capital. Okay, so we have established these edges as well. Now which are the edges remaining? So here we have between BI and BC. Okay, so these two edges we need to make. So I'll do something like add edge between B and I, B and C, B and I, and B and C. And now we have an edge between CD and DE. Okay, so I'll do something like add edge CD and add edge D and E. Okay, so CD and DE, CD and DE. Okay, so we are done with all the edges. Okay, so this establishes all our edges. So after these add edge statements, our graph, this particular graph over here would have been established, right? So let's write a function that can print the entire graph. Okay, so basically the adjacency list I want to print, like which all the users have which all connections in their adjacency list, right? So what do I mean by that is, me should be having F, B and A in the connection set. A should be having me, G and H in the connection set. D should be having E and C in the connection set. Okay, so I just want to verify this particular data over here. Okay, so let's write a function that can print the graph. So I would write something like void. Okay, so this is capital. Okay, so void print graph. Okay, and here what I'll do is I'll just write a simple cout statement that adjacency list is okay. And what I'm going to do is I'm just going to iterate upon the map that we have over here. That is the LinkedIn user map. Okay, so I'm just going to iterate upon the map. So I'll just say auto user of LinkedIn user. Okay, so first I'm going to print the username of the user. So where would the username be present? So either you can just print the user.first variable. So here we have the first parameter to be of string type, right? So this is storing the username, and the second parameter is the user object. So either you print the user.first or you can print the user.second.username, right? So both of these would be printing the same value. So I'll just do username user.first. Okay, so this would be printing the username. Now for this username, I want to see which are the connections of this particular username. So I'll just simply iterate on the connection set. So I'll just say for auto connection in user.second.connection. Okay, user.second.connections. I would just print the connection name. Okay, cout connection, and leave a space or maybe a command between them. Okay, and after this entire for loop is processed, I'll just simply write cout end line. Okay, so here we missed a semicolon. All right, so this would basically leave a line after printing all the connection name, and then the second user username would be printed, and then all the connection of the second user, third user, and like that it will be printing. So now let's call our print graph function or the main function. So just to verify that our graph has been established correctly. So I'll just say print graph. Okay, so now let's just run our program to see whether our graph has been established properly or not. Okay, so I'll just go ahead and compile the program. So I'll just say G++ LinkedIn BFS, LinkedIn BFS.cpp. So before I actually run this particular program, let me write a function that can reclaim the memory that are used by this new keyword. So ultimately, when the program terminates, this memory would be reclaimed back, but just for a better practice, I'll write something like this. So I'll just say clear memory. Okay, and here in the clear memory function, I will be writing something like memory, and so we just iterate upon this map and just claim the memory that is occupied by the second variable over here. Okay, so what I'll do is for auto user in LinkedIn user, what I'll do is I'll just do delete user.second. Okay, so user.second is basically the reference to the heap memory that we have over here. So we just make use of the delete keyword along with user.second, and this will iterate upon all these objects that are initialized by the new keyword and reclaim the memory from them. Okay, so this is a clear memory function. So let me recompile this program again and let us see the output. Okay, so note that as of now we haven't implemented our BFS function. We are just simply printing the adjacency graph that we have established. Okay, so I'll just do ./a.exe. So here we can see that the username A has G, H and me over here. So let me verify with our diagram. So let me put it over here, right? So the adjacency list is, so the username A has G, H and me. Username A has G, H and me in the adjacency list, which is correct. Username B has C, I and me. So B has C, I and me. Okay, so C has B and D. Where is C? So C has B and D, which is correct. C has B and D, okay, which is correct. And then you have D, which has C and E. D has C and E. Then E has D. E has only D. F has only me. F has only me. Okay. Username G has A. G has only A. Then you have H has only A. Okay, that is also correct. I has only B. I has only B. Okay. Then username me has A, B and F. Username me has A, B and F. So with this, we can claim that our adjacency list is represented perfectly in our code. Okay, so now next step would be to implement our actual BFS function. Okay, so the BFS function that we are going to be implementing would be taking an initial node as the argument. So this is the node where we are going to begin our journey. Okay, our journey of BFS. Basically, from which LinkedIn user's perspective are we evaluating this first, second and third? Okay, so here it will be me. So from me, these nodes are the first level nodes, then you have the second level nodes, then you have the third level nodes, etc, etc. Now similarly, if you pass the node C to the BFS function, so for the LinkedIn user C, B and D would be the first level connection, that is the direct connection. I, me and E would be the second degree connection. Okay, and so on and so forth, it will go on. Right? So the LinkedIn user or the node that you are passing into the BFS function is our initial node. Okay, so let's implement our BFS function. So our BFS function will look something like this. So void BFS, and we need to accept our initial node. Okay, so we'll accept the initial node username. Okay, that's the reason why I'm using a string initial node. Okay, so it will be accepting something like me or A or B, etc, etc. So this kind of input would be given to the BFS function. Okay, so as you all know, what exactly do we need for the BFS function? The very first thing that we need is the queue data structure. So this queue would be containing the list of all the usernames that we need to process one by one. So that's the reason why I'm declaring the queue of type string. Okay, so queue string username queue, I'll name it as username queue. Okay, then if you remember from my previous video, we need to also maintain something called as visited array. But since here we have a values of type string, so let's maintain a set in order to store the visited information. Okay, so I'll be declaring something like unordered set. Okay, unordered set of string, and here I'll just name it as visited connections. Okay, so this is going to be our visited, going to contain our visited node information. Okay, and this is going to contain the usernames in the order they need to be processed via the BFS algo. Okay, so as of now we have declared our queue data structure, and we have also declared our data structure to store the visited information. राइट सो अब क्या करेंगे कि हम एक डेटा स्ट्रक्चर स्टोर करेंगे जिसमें हम यूज़र नेम टू द लेवल इन्फॉर्मेशन वी कैन स्टोर. ओके, सो व्हाट डू आई मीन बाय दैट इज, say for example here the B is at first level, right? B, A and F are first level, then I, C and G and H are at second level. So this kind of information we want to store in a data structure. ठीक है, कौन सा लेवल पे कौन सा नोड आ रहा है, so that we want to store in a data structure. So for that I am going to declare a map of string and int. So this string would be containing the username, and the second parameter over here would be containing the level of that particular username. Okay, so I'll just name it to be user to level. Okay, and then the current level, like whenever you are starting the BFS journey, right? So the current level will always be 0. Okay, current level is equal to 0, right? So here in this particular example, the me node, right? The place where you're starting your BFS journey. So this would always be at level 0. Then you have level first, then you have level second, then you have level third, and then beyond the third level, it will be considered as others. Okay, so the initial node, since it is at level 0, I'll declare the variable current level to be equal to 0. Okay, so now what we need to do is we need to push the initial node. So if you remember the BFS algorithm, we used to push the initial node into the queue first. So what I'll do is I'll just put username queue dot push initial node. Okay, so I push the initial node, and let me also store the user to level of initial node to be equal to the current level. Okay, so this will basically put the node me to be at the level 0. So current level is storing the value 0, right? So here the value 0 would be put against me. So after this statement, it will be something like me and 0. So this kind of value would be stored inside our map. Okay, so now what I need to do is I need to mark the initial node to be visited. Okay, so what I'll do is I'll just say visited connections dot insert. Okay, visited connection dot insert, I'll say initial node. Okay, so this is going to be mark. So this statement is going to mark the initial node to be visited. And now what I'm going to do is I'm just going to trigger the while loop while username queue dot empty, while username queue is not empty. Okay, while not username queue dot empty, जब तक username वाला queue खाली नहीं हो जाता, what we need to do is we need to get the front element. Okay, so how do we get? So we'll write something like front username is equal to username queue dot front. Okay, so username queue dot front will give you the username that is present in the front, and we also need to remove the username from the front. So what are these two lines doing? So we need to get the front element from the queue and remove it from the queue as well. Okay, so these two statements are basically doing that. So now we have the front username, right? So let's get the user object associated with this username. Okay, so what we need to do is we need to get the user object associated with the front username. And how do we do that? I'll declare a variable called LinkedIn user. Front user is equal to LinkedIn user is equal to LinkedIn user of front username. Okay, so this is our map, right? So that we have declared over here. Where is that? So here we have the map declared, and it simply says that just give me the username, I'll give you the user object. Okay, just give me the username, I'll give you the user object. Okay, so the same thing we are doing over here. We are just making use of the map that we have already declared, that is LinkedIn user wala jo map hai. उसमें we are passing our front username that is there in the queue. ठीक है, front username we are passing, and it will return us the address of the username, right? So we are storing that in the front user. ठीक है? Okay, so now we got our front user. Now we need to update the current level. Okay, so we need to update the current level to the user to level of front user. Okay, so this is we are getting. So this user to level, that information that we are maintaining here, right? So this would give us the level that this front user is available at. Okay, so why do we need this particular current level? It's because when we are pushing more elements into the queue, right? Whenever we are pushing more elements to the queue, we need to push it with a level equal to current level plus 1. Okay, so current level plus 1 in the sense that, so this me node, right? So this me node would be at level 0. Now when we want to push the node B to the queue, push the node F to the queue, or push the node A to the queue, we need to push it at the level 0 plus 1. Okay, so these need to be pushed with a level 1 associated with it. Okay, so the nodes G and H, if at all they are being pushed into the queue, they need to be pushed with the level 2, which will be equal to the level of A plus 1. So level of A would give us 1 and plus 1 will give us 2. Okay, that's the reason why we are writing this kind of sentence over here. That is current level. We just update our current level, that is like initially 0 tha, and then the element that we had pushed over here. So we are updating the current level to the level of the front username, so that when we are pushing elements using the for loop below, which I'm going to implement right now. So when we are pushing those elements, right, we are just putting those elements with the level equal to current level plus 1. Okay, this will become more clear when I write the code below. So this current level variable has been updated. Now what I'll do is I'll just do the processing part. So what you can do is you can simply do front user of print user. Okay, so this print user function we have declared over here. So inside this LinkedIn user class. Okay, so let's consider that print user function if at all is executing. So we are just processing the node. So for every node, it will just print the name. It will print the total skills and total connections. Okay, so that let's consider that to be the processing part in the BFS algorithm. So here we are doing the processing of the node. Okay, so once the processing is done, what I'm going to do is I'm just going to see which are the neighbors of that particular node. Okay, so here which are the neighbors of the me node, which are the neighbors of B node, etc etc. Okay, so this neighbors के ऊपर जो for loop हम मारते हैं, right? So if at all they are not visited, we just push them into the queue, and if at all they are visited, we simply ignore. ठीक है, so that logic we need to write over here. So I'll just simply say for string neighbor. Okay, for string neighbor in front user of connections. Okay, front user of connections. The front user of connection will give you all the neighbors of that particular connection. Okay, so what we need to do over here is we just need to check. Okay, we just need to check if this neighbor is already visited or not. Okay, so we just need to check whether this username. So for readability, let me write it as neighbor username. Okay, so what we need to do now is we just need to check whether this neighbor username is present in this visited connection wala set or not. And how do we do that check? So we just simply write visited connections dot find, and I'll just say neighbor username is not equal to, if at all it's not equal to visited connections dot end. If at all it's not equal to visited connections dot end, that means it's already visited, right? Okay, so we simply need to ignore. Or what we can do is we can just check for equal to. If at all it is equal to visited connection dot end, which means that the neighbor username is not present in the visited connection wala set. I hope you are familiar with this find wala syntax. Okay, so visited connection dot find, if at all is equal to visited connection dot end, that means neighbor username is not found in the visited connection. And so what we need to do is we need to push inside the username queue dot push the neighbor username. Okay, so we need to push the neighbor username into the username queue. Okay, the BFS queue that we are maintaining, we just push the neighbor username. Okay, and we need to update the user to level of neighbor username equal to current level plus 1. Okay, so current level plus 1, why is the current level plus 1? So as I told you, right, so here if we are talking about B, right, and if you want to push the element I and C into the queue, I and C need to be pushed with a level equal to 2. Okay, so this is equal to level of B, that is 1 plus 1. Okay, level of B plus 1. So that's the same thing that we are doing over here. So current level plus 1. And what exactly is the current level? So current level we were updating over here, right? So current level is equal to user to level of front username. I hope you got this particular logic. Okay, so now we have stored the user to level of neighbor username. What we need to do is we need to mark this node to be visited. So visited connections dot insert, I'll say neighbor username. Okay, so I'll just say visited connection dot insert neighbor username. Cool. Okay, so after this entire while loop is finished processing, our user to level map would be filled with username to the level mapping. Okay, so it will be storing something like me is equal to 0, A is equal to 1, F is equal to 1, B is equal to 1, I is equal to 2, C is equal to 2, G is equal to 2, H is equal to 2, D is equal to 3, E is equal to 4, Okay, so this kind of information would be present inside our user2 level wala variable, and what we need to simply do is we just need to simply print the key and the value pairs of this user2 level wala variable. Okay, so how do we do that? So let me write a cout statement. Cout level 2 connections are shown here, and I'll say for, okay, for auto user in user2 level, okay, and I'll simply say user dot first, that is like username, is at level user dot second, and I can also write from initial node. Okay, so this is going to print our user to user level mapping. So let's simply run our program to see what output do we get over here. Okay, so I'll simply run BFS of, let me run it on me. Okay, so BFS of me would trigger the BFS function over here, and let's see what output do we get. So I'll simply write g++ and LinkedIn bfs.cpp, and I'll say /a.exe. Okay, so here you can see that first it is printing these values, that is like the processing of the BFS part. Okay, and then here we can see that level 2 connection are shown over here. So here we can see that A is at level 1 from me, B is at level 1 from me. Let me place it next to the diagram that we have. Okay, so here is the diagram and here is the output. Okay, so let's verify our results. So here we can see that A is at a level 1 from me. Where is A? So A is at a level 1 from me, that is correct. B is at a level 1 from me, that is also correct. C is at level 2 from me. So where is C? So C here is at level 2, that is second level. D is at level 3 from me. So where is D? So D is over here. So D is at third level, as you can see over here. E is at level 4. F is at level 1. G is at level 2. F is at level 1. G is at level 2. H is at level 2. And I is at level 2. Where is I? I is at level 2. And me is at level 0 from me. Okay, so me is at level 0 from me. Now here we can see that here we are getting the output to be 4. Okay, how do we improve this scenario? How do we eliminate 4 and rather print some other value? Okay, so for that what we can do is we can just modify this for loop. So for that what I can do is I can just declare a variable called permissible levels. So I will have where is my, so I will declare something called vector of int and permissible, or maybe I'll just declare a set of int permissible levels. Okay, permissible levels, and I can have 1, 2 and 3 inside the set. Okay, and here what I can simply do is, and here I can simply do an if statement. If permissible levels dot find, if permissible level dot find user dot second is equal to permissible level dot end, that means it is that means the level is not among the permissible levels. So what I can do is I can simply print cout is at level others, is at level others from initial node, otherwise else we can print this particular thing, that is user dot first is at level this. Now one more thing that we are missing is the level 0. So what we can say is if user dot first is equal to initial node. Okay, so we can simply do continue. Okay, we can simply continue the loop, that is like we do not print any cout statement, right? So let's run the program again. So I'll simply write g++ LinkedIn bfs.cpp, and I'll just write /a.exe. Okay, so here we can see that A is at level 1 from this thing, and E is at level others from me, and we do not have any mention about me because we started our journey from me, right? Now let's change our initial node from me to one of the nodes over here. So let me change it to A. Okay, and then let's try to run this particular BFS program. So I'll say g++ LinkedIn BFS .cpp, and then I'll do /a.exe. Okay, so let's see the output over here. So here we can see we have B, C, D, E, F, G, H, I, and in the diagram over here, so we had selected our initial node to be A. Now from A, which are the first level nodes, so here we have first level node to be me, G, and H. So let's see over here. So H is the first level node, then you have G at the first level, and then me at the first level. Okay, then which are the second level nodes? So second level nodes would be F and B. Okay, so here let's see where 2 is. So here you have F is at level 2 from A and B is at level 2 from A. Okay, so this is also correct. And then at the third level we have I and C. So here we can see that I is there at the third level and C is there at the third level, and anything beyond the third level would be considered as others, and that's the reason why we have D, the node D, to be labeled as others, and also E is labeled as others. So this was the program about running BFS on LinkedIn connections. Hope you like this particular example. Okay, so thanks for watching.